To start this problem, we can first write down the basic force formula. F is equal to ma. And you can recognize that acceleration is just dv over dt, right? And since we're trying to find the momentum balance equation, we need to remember that momentum is equal to m times v, right? And so in order to get this equation, we can actually multiply both sides by dt, so we get f dt on one side and then m dv on the other. But in a momentum balance equation, both the mass and the velocity aren't constants. They aren't constants in a momentum balance equation. So both of them are of d. So this is basically the same as just d of p, but we're just going to keep it as d of m times v, right? Let's rewrite this equation a little more. So we're going to write this as d of m times v of the system, right? And so we start with the initial force put into the system, right? So like you kick a ball, and that basically kickstarts the entire system. But in a momentum system, we can add momentum as well. And so again, momentum is m times v. So in this case, there will be a velocity going into the system times this by a mass also going into the system, but that mass can differ. So we have to write that as d of the mass going in, right? So this is momentum going in. And naturally, there will also be momentum going out of the system. So that's basically the same thing, but instead of v in, it's v out times this by the d of m, or the d of the mass going out. It's d of m because, again, mass is not a constant in this case. And so this is p leaving the system, right? And so in order to make this system, based on time, based on changing time, we can actually divide everything by dt, right? And so when we do that, F is then isolated, which again, F is the initial force put into the system, but then now everything is divided by dt. And so with that, this right here is the momentum balance equation for flowing systems.